Well, on page 158, example 5, it's asking us to graph by making a table. And they're giving us 3 equations here. I'm only going to use one of those to make a table, but I am going to discuss these bottom 2 where x equals 3 and y equals -2, and then we will graph it, but I'm not going to use making a table. Now, as I explained before when we were looking at graphing by using the intercepts, I only need 2 points on a linear function to accurately graph that. But you can see here that I have put together a table, and we're going to use this, and we're going to go get 3 points from this equation right here. 2x minus y equals 2. And so if I am making a table, I'm going to substitute for x, the values that I have represented here on the table. So let's see, we start with -1. So I got 2 times -1 minus y equals 2. Well, 2 times -1 is -2 minus y equals 2. And we're going to add 2 to both sides. And when we do, we got negative y, equals 2 plus 2 is 4. And then I've got that negative in front of that y, so I need to divide both sides by -1, which is going to change the signs of both terms, so where y is equal to -4. And so then when x is -1, y is equal to -4. All right, then we're going to substitute in 0 for x. Well, 2 times 0 is just 0, and that's going to leave me with -y equals 2. And again, I'm going to divide both sides of this equation by -1. And so when x is 0, y is equal to -2. And I'm just going to put that in my table, -2. And then lastly, we're going to substitute 1 in for x. So here I got 2 times 1, substituting the 1 for x, minus y equals 2. Well, 2 times 2 is 2. 2 minus -y equals 2. I'm going to subtract 2 from both sides of this equation. That's leaving me now the result is -y is equal to 0, positive 2 minus 2. And I can go ahead and divide by -1, but 0 is 0, so y is going to be equal to 0 when x is equal to 1. And therefore, that actually is my y-intercept. And when x is 0, y is equal to -2. I'm sorry, that's my x-intercept. Then that's my y-intercept at -2. My x-intercept is at when y is equal to 0, x is equal to 1. Now, like I said, I'm not going to graph these, but I do want to describe for you what you're going to see. So if I see x is equal to 3, that is going to graph as a vertical line at x equals 3. And so when x is 3 in that equation, y can equal anything and everything, out to infinity, out to -infinity. It's just going to be a vertical line. No matter what the value of y is, x still equals 3. And in the third equation, y equals -2, well, that's going to be a horizontal line. Again, y is always going to equal -2 no matter what the value of x. And we'll graph those here in a moment as we go in. But we're also going to graph these coordinates. Let's jot those down. Let me jot those down. We got -1, 4, -4, -1, -4, 0, -2, and 1, 0. Let's jump over. We'll do a little quick graphing, and we'll get out of here. All right, we're over here in our graph paper. Let me see. I'm going to move this around a little bit. Let me scoot this graph right there. All right, so the first thing we want to do, we want to graph that first equation that we had, which was 2x minus y equals 2. We made a table from that, and we got 3 ordered pair. And so let's see, let me grab the point. I want to grab a point. And let's put in our first coordinate, which was -1, -4. And I see that point pop up. And then my next ordered pair I had was 0, -2 from my table. And let's hit equal there. I see that y-intercept pop up when x is equal to 0. My third point was 1, 0. And shazam, there we go. And let's see. Let's get a line. We're going to put them through point A, point B, point C. I don't want to do that. Stop, stop, stop. Anyway, there we go. Well, it just wants to keep on going. Let me line it back up. But anyway, there's our graph of that function. And if you look right over here to the left, up here, I see that exact equation. -2x plus y equals 2. It's a -2x. If I divided everything by -1, I'd get our exact equation, which was 2x minus y equals 2. Now, let's go and graph x equals, what was it, 3, and then we'll graph y equals 2. And I'm going to go up here and I want to say I want to get a new graph. New, don't save. Okay. Huh. Well, I left my thing in there anyway. Let me say I want a new graph again. New, don't save. Okay. Let me go to my little hand feature, my arrow feature. I'm going to move this over a little bit. And I'm going to say I want a line. I'm going to say I want a line. And I'm going to put in here x equals, +3. And we're going to hit enter. And here you can see I've got a line right here. It's a vertical line. And when x equals 3, it forms a vertical line. Now, this is not a function. This is a relation. It's not a function because it can't pass the vertical line test. And if we hadn't already talked about that, we certainly will talk about that a little bit later. Let's enter in our second equation where y equals -2. And again, you can see that that has created a horizontal line. No matter what the value of x is, x could be -12, and y is going to equal -2. Or x could equal +12, and y is going to equal -2. Now, this horizontal line is a function. It's called a constant function when we get into the world of parent functions. And it is linear. It's a straight line. So there we go. We've graphed a linear function, 2x minus y equals 2, derived from coordinates or ordered pair that we got from a table. And we have graphed the graph when x is just equal to 3. That gives us a vertical line. And we graphed y equals -2, which just gives us a horizontal line. So much fun, so much fun. We're going to continue working on linear functions.